Hello everyone, our focus for this video is going to be on the laws of exponent, otherwise known as the laws of indices, right? Whenever we have variables which contain exponents and have equal bases, we can do certain mathematical operations to them. Those operations are called the laws of exponents or the laws of indices, right? Now here, if we have b raised to the power of x, then b is equal to the base and x is equal to the exponent. Another word for exponent is what we call the index or the power, okay? Now, let's go through the different laws of exponents. The first one that we're going to look at is number one. We have a variable x is raised to another variable, which is the power in this case, or the index, which is m times x to the n. Whenever you have this, then this is equal to x raised to the power of m plus n. So once the base are the same, and as you can see here, the base is x, then you just simply add the exponents, or you add the index, or you can say you add the powers. Let's look at law number 2. If you have xy in a bracket, right, raised to some power m, then this is equal to x to the m times y to the m. What this means, note that xy means x to the first power and y to the first power. So you take whatever power outside of the bracket to multiply each power inside of the bracket. All right? Let's look at law number 3. x to the power of m raised to the power of n. Then this is equal to x to the power of mn. What you are doing, it is similar to law 2, which is just multiplying the powers. That's how you get mn there. Law number 4. You have x divided by y all raised to the power of m. Then this is equal to x to the m all divided by y to the m. And it's similar to law number 3. You're just taking the power outside of the bracket to multiply the power of the numerator. That gives you x to the m. And you take the power outside of the bracket to multiply the power of the denominator. Alright? That's the same thing. Law number 5 is divided into part A and part B. Let's look at part A. If m greater than n, then x to the m divided by x to the n is equal to x to the m minus n. Alright? So this is applying to division. So once the base are the same, we simply subtract the power. Now part B of this law. If n is greater than m, then x to the m divided by x to the n is equal to 1 over x to the n minus m. Alright? Other properties of exponents. If we have x raised to the power of 0, then this is equal to 1. Right? Therefore, if you have 5 raised to the power of 0, then that is just simply 1. 100 raised to the power of 0, that is equal to 1. Any variable at all raised to the power of 0 is going to equal to 1. Alright? Other properties is the inverse, negative property. So here we have x to the negative 1 is equal to 1 over x. Alright? Any single number or variable is always to the first power. So for example, here, if you have 3, 3 is the same thing as 3 to the 1. a is the same thing as a to the 1. 2x is the same thing as 2 to the 1 x to the 1, which is equal to 2x to the power of 1. So whenever you see a number by itself, remember that it is raised to the power of 1. All right. Now let's look at some basic examples of how these laws are applied to various questions. Now the first example I have here is x squared times x to the third power. Note the bases are the same, which is x. So therefore, my next step is going to be x raised to the second power plus the third power. So that's what the first law taught us to do. Once the bases are the same, we simply add the index. So here we have x to the second power plus the third power, which is give us x to the fifth power. All right. Let's look at another example. Now we have x to the fourth power raised to the third power. Now the law of indices states that we should multiply the powers. So our next step is going to be x to the fourth power times the third power, right? And that's how you would write it there. The dot means multiply, which gives us a final answer of x to the 12th power, all right? Let's look at another example. Here we have xy to the third power. Now what this is basically going to equal to, we're just going to take that power outside to multiply the power inside. And remember that x by itself means x to the 1 and y to the 1. So that's going to give us a final answer of x to the third power and y to the third power. All right. Continuing with some more example. Now we have x over y to the third power. And that's just basically equal to x to the third power divided by y to the third power. All right. Next example. Here we have x to the 7th power divided by x to the 4th power. The bases are the same. We just simply subtract the powers. So that our final answer is going to be x to the 7th power minus the 4th power all over 1 basically. So that's how you would write it. And that's going to give us a final answer of x to the 3rd power. So let's look at another example. Here, this example, we have x to the 5th divided by x to the 7th. Now this is going to equal to 1 over x to the 7 minus 5. So once you are asked to divide and you note that the power in the numerator is smaller than the one in the denominator, then it is 1 over x to the 7 minus 5. This is how you would write it. And that is going to give you a final answer of 1 over x squared. All right. Continuing with some more examples. So now we're going to some more complex example. So here we have 2a to the 3rd power times 7a to the 4th power. What you're going to do is to take the coefficient of the first term and the coefficient of the second term and multiply them together and place them in a bracket. Then note that you would have had a to the 3rd power and a to the 4th. So you're just going to write 1a and just simply add the power, which is 3 and 4. And this is how you would basically do it. So here you would have 2 times 7 times a to the 3 plus 4, which is going to give you a final answer of 27, which is 14, and a to the 3 plus 4, which is going to give you 14a to the 7th power, right? Next example. Here we have negative 5r squared times 8r cubed times 2r squared. Same idea like the first one. We're going to take all the coefficients and multiply them together and put them in a bracket. Then we're going to take 1r and then we're going to raise it to the power of 2 plus 3 plus 2. And this is how you would write that. All right. After you have done that, what you're going to do now is to multiply out the coefficients. So you're going to multiply -5 times 8, which is going to give you 40, times 2, which is going to give you -80, right? So here and then you simply just add the index, which is 2 plus 3 is 5 plus 2, which is 7. So your final answer is simply going to be -80r to the 7th power. All right. Next example. Here you have 2m squared n to the 5th power all raised to the 3rd power. Note that 2 here is raised to the 1st power, right? As you would have known. So all you're going to do is to take the power outside the bracket to multiply the power of each term inside of the bracket. And this is how you would simply do that. So it would equal to 2 to the 1 times 3 and m to the 2 times 3 and n to the 5 times 3. Then you're simply going to combine this, which is going to give you 2 to the 3rd and then m to the 6th and then n to the 15th, right? And this is how you would write that. Now you still can simplify this further because 2 to the 3rd power means that you must multiply 2 3 times. So you're going to multiply 2 times 2 times 2. And 2 times 2, that's 4, and 4 times 2, that's going to give you 8. So this can further simplify to give you 8 m to the 6th power and n to the 15th power. All right? And that's it there. Let's look at another example. Here we have a pretty simple one, which is 3xy to the 3rd power. Similar to this one, remember that each term here is raised to the power of 1, and 1 times anything doesn't change it. So here, this is going to give us an answer of 3 to the 3rd power and x to the 3rd power and y to the 3rd power. Right? And that's how you would write it there. Now this can further simplify by breaking down 3 to the 3rd power, which is just the same thing as 27, x to the 3rd power and y to the 3rd power. All right. Let's look at another one. Here we have 2a all divided by 3b, all of that raised to the 2nd power. So what this means that we are squaring, right? What this means that we are taking the numerator and we are raising it to the 2nd power, right? And we are taking the denominator and we are raising it to the 2nd power. In other words, whatever power is inside of the bracket, you are multiplying the power outside of the bracket by the power inside, right? But note that each of the power inside here is just basically 1. So what this is going to give you is actually 2 to the 2nd power and a to the 2nd power all divided by 3 to the 2nd power all divided by b to the 2nd power. And this is how you would basically write it, right? You can further simplify that because 2 squared is actually going to give you 4. So what you're going to have for the numerator is actually 4a squared, and 3 squared is actually 9. So the denominator is going to be 9b squared. So that's your final answer there. Let's look at another one. Now here we have 8x to the 4th power all divided by 2x. Now this is the same thing as the saying 8 divided by 2 and x to the 4th power minus 1, because x by itself is raised to the power of 1, and this is how you write it. So here you can clearly see that this is 8 divided by 2 all over x to the 4th power minus 1, right? And that will give you a final answer of 4x. Let's look at another problem. So here we have 9z to the 3rd power all divided by 3z to the 5th power. Note that the power of the z term in the numerator is smaller than the power of the z term in the denominator. So what I'm going to do, the easiest way to do this is to take 9 and divide it by 3. Then remember that I must put 1 over z to the 5th minus 3. And this is how you would write that. So it would be 9 divided by 3 times 1 over z to the 5 minus 3. Now 9 divided by 3, that's just going to give us 3, and 1 over x squared, which is just the same thing as just 3 over x squared. All right. Next example here. Here we have 3x squared y squared z times 7xy z squared. Same idea. Multiply the coefficient. So the first thing we're going to do, we're going to take the 3 to multiply this 7. Then note here the second term is x cubed. Here this is x to the 1. So we're going to write back 1x and add the power. So it's going to be 3 plus this 1. Then the same idea for this one is going to be y to the 2 plus 1. Then this one is going to be z to the 1 plus 2. So this is how you would write it, right? Clear here, right? So 3 times 7, that's going to give us 21. And this is going to be x to the 4th, y to the 3, and z to the 3. All right? So that's it there. 21x to the 4th, y to the 3rd, and z to the 3. Let's look at another example. So here we have negative 8xy squared times 3xy times negative 2xy cubed. Similar to this one, so what we're going to do, take all the coefficient and multiply them. So we're going to multiply negative 8 by 3 by negative 2. Put that in a bracket. Then we're going to take this x. X here is raised to the first power, so it's going to be x to the 1 plus this 1 plus this 1 here. Then it's going to be y to the second power plus this 1 power here plus this 3. And this is how you would basically write it, as negative 8 times 3 times negative 2 times x to the 1 plus 1 plus 1 and y to the 2 plus 1 plus 3. And you just simply simplify this. So here 3 times negative 8, that's going to give us negative 24, and negative 24 times a negative 2, that's going to give us negative 48, x to the 3rd and y to the 6th. So this is our final answer here, 48x to the 3rd and y to the 6th. Let's look at another example. Here you are given 3x squared y to the 3rd in bracket times all of that, all squared, times 2x y squared to the squared, right? So first, you're going to take this 2 to multiply each power in the first bracket. And then you're going to take this 2 to multiply each power in the second bracket. And this is how you would write it. So here, it's going to be 3 to the 1 times 2. Then x to the 2 times 2. And then y to the 3 times 2. So in other words, I basically distribute this power that is outside of the bracket with each power inside of the bracket. And the same is true for the second one, which is just 2 to the 1 times 2 and x to the 1 times 2 and y to the 2 times 2. What I'm going to do is to just simplify this. So if you simplify this, 1 times 2, that's just going to be 2. So if you simplify it, this is what you basically will get, which is actually going to be 9 here, because 1 times 2, that's just 3 square, and 3 square is basically just 9. So we're going to get 9 to the x to the 4th and y to the 6th times 4 to the x squared and y to the 4th. But we are not finished yet. Here, all you're going to do is to take the coefficient. So you're going to multiply 9 times 4, which is going to give us 36. And then here you're going to put x and add 4 plus 2, and then y to the 6 plus 4. All right, which gives you a final answer. So this is how you would actually write it. So this is how you would actually write it. So it would be clear here, which is just 9 times 4, x to the 4 plus 2, and y to the 6 plus 4, which gives you a final answer of 36, x to the 6 and y to the 10. All right. Let's look at our final example here. Here we have 5, a to the third, b to the first, all divided by 3a, b squared, all to the third power. So again, we're going to take the power and distribute it to all the powers inside of the bracket. All right, and this is how you would actually do that. So here it's going to be 5 to the 1 times 3, then a to the 3 times 3, and then b to the 1 times 3, all divided by 3 to the 1 times 3 over a to the 1 times 3 over b to the 2 times 3. All right, then this can further simplify to give 5 to the third, a to the 9, b to the third, all divided by 3 to the third, a to the third, and b to the 6. Now note that 5 to the third is just 125, and 3 to the third is just 27. So you can further go to simplify that to give you 125, a to the 9, b to the 3, all divided by 27, a to the third, b to the 6. Now remember, here, what we can do is to just basically separate this a little bit. So what we can do is to write 125 divided by 27. Then it's going to be a to the 9 minus this 3. And because I don't want to work with a negative here, then I'm going to put 1 divided by b to the 6 minus 3. And this is how you would write it. So there, it's just basically 125 over 27, and a to the 9 minus 3 over b to the 6 minus 3, right? Which gives you a final answer of 125 e to the 6, all divided by 27 b to the third. All right. Thank you for watching, and I hope that this video would have helped you to understand the different laws of exponents or laws of indices, and understand how to apply them to different kinds of questions. If you are new to this channel, please remember to like, subscribe, share, and leave a comment.